She was.
Because like,
Okay.
I like
Alright, so we are going to do more practice today. More practice, and then we'll do something a little more fun. Let's quickly just do a few problems. I'll walk through a few of the types of problems we'll be seeing on the test, and then after that, I'll let y'all do some of the problems, and then we'll go into it. So, let's start with what?
Study guide's going to be due by, no, it's either 5 or 6 o'clock tomorrow. Let's just say 5 o'clock tomorrow afternoon, and I'm going to post the answers between 5 and 6.
So we're not going over the study guide necessarily today, just because we need to get a ton of practice on these electron configurations, and that's where the majority of it's going to be. So, let's start with silicon. So we're going to try to do the electron configuration of silicon. So
Is this harder or less hard than the last one?
that depends on your perspective. Depends on what you're struggling with. So we're going to start with silicon. So, silicon. So where is silicon on the periodic table?
Right there. 14.
14, thank you. I can't really see it right there when I'm not seeing it. But yeah, so number 14. So let's go through our electron configuration. So how should we start this?
1s squared.
1s, well not squared, but 2, right? Yeah. And then what else?
2s2.
2s2, okay.
2p2. I mean 2p6.
2p6, right?
3s2.
Alright.
And then 3p2.
3s2, and you say 3p2. So why is it 3p2?
Because it stops at the second one of the 6.
The second one in the 6, right? And that 6 on the side represents what orbital?
P.
P orbital, right? So we know we have 2 more electrons in that P orbital. We just need to fill it up to this point. We're done here, right? What? Yeah, Madison?
sorry, just what you said.
What? You're good?
Well, no, but you might have said what I was gonna ask.
Okay. What were you gonna ask? Just go ahead.
Could you replace the 1s squared through 2p6 with any?
Yes, you can. You can, and that's exactly what I was gonna say. You're exactly right. So I was about to ask what the noble gas notation was for this, and yeah, but the easy answer here is just neon here takes the place of all this, because again, this 1s2, 2s2, 2p6 all can fall under neon, and then we have our 3s2, 3p2. Here's another question: if we're trying to do the electron configuration for neon, can we just put this, or is that being too lazy? Being lazy, right? How should we write this?
1s2, 2s2, 2p6.
And then if we're going to write the noble gas notation of this, we're going to
Be one hydrogen.
hydrogen?
Helium.
Helium.
Gosh, bro.
It's hard to read.
2s2, 2p6.
Yeah, exactly. So always make sure that you go back to the last one, even on these noble gas the noble gases themselves. You can't just put down any, because then I have no idea what you're talking about at that point. You're just throwing down the element again. Yeah.
Are we going to be able to use our periodic table on this?
Yeah.
Well, it won't be the same one that you have because the electron configuration is on it.
Oh, yeah.
Yeah.
Oh, I didn't know that. I didn't even realize that.
Well, you know, for the first 10 years I taught, I probably didn't pick up on that, but I got smarter.
You know there was that student named like Emily or something that called him out.
So you will have a periodic table, but it'll be very generic.
That'd be Caroline.
Wait, no, it wouldn't say.
Okay. So does that make sense on electron configuration for everybody? Do we understand how to do these fairly well?
Yeah, it's just like I'm the person.
Gotcha. Okay, perfect. A lot of these are just kind of counting, same with
Actually, it just has a noble gas.
By the way, we're going to talk about, like, let's say we make a fake an arrow diagram here, and we're talking about the last electron in this and this 2p6. What would be the quantum numbers for it? Let's start with Q. What do we think the quantum number for Q is going to be here?
Q-N.
Yeah.
And why am I brain? I said quantum and I said Q. That's my brain's not connecting to me. And what's N?
Two.
2. All right. What's L?
L is P.
0, 1,
1.
0 or 1? Which one is it?
1.
1. I heard 1.
Because it's
Okay.
P
1 is equal to what? I heard it. I heard somebody say it. 1 is equal
to P.
to P. Yeah. 1 is equal to P. All right. N sub L. What do we got?
It's gonna be,
So we're gonna assume that this is filled to left to right, just like the typewriter, like
it's gonna be 1.
1, right? Because again, we have 3 suborbitals, right? Or sub 3 orbitals inside this p subshell here, and so we've got this. We've got our negative 1, 0, 1, and like I said, left to right, gonna be right here. Okay. And then what about our?
either one, because we don't.
Yeah, it could be either one for N sub S. Generally, the first one that you put in, we assume negative 1/2, and the second one you assume positive 1/2. That's just a general rule, and again, it doesn't really matter. But just for the sake of consistency, I'm going to put down positive 1/2 here. But again, you're absolutely right; it could be either one. All right. Seems like we got a pretty good handle on these. So,
Wait, I thought it had to be negative 1/2 since it was neon.
for
Like,
neon.
since it was 10.
No,
that's-
so that, we're talking about just the spin itself, right? So you remember in an orbital, you have one spin going up, one spin going down.
See, I thought that first up arrow, I thought that would be boron. And then,
Yeah, so we were talking about this arrow.
so wouldn't it be negative 1/2?
Would be negative. So generally, when you were representing these, I know it's a little confusing, but when these up arrows were representing as negative 1/2 normally, and these is positive 1/2.
Oh, okay.
But remember, we're dealing with what? What are we dealing with in these orbitals? What is this?
Up arrow?
What is it representing? What is the up arrow representing?
What's the S and M sub
The
S?
spin.
Spin.
Which direction?
So this is an electron, right? So generally, we like to use negative for electrons for positive. But yeah, we're dealing with N sub S, so again, it doesn't really matter which way you represent it. That's just the way I was drilled in college. Is that a plus, or going up is the negative 1/2, and going down is the plus 1/2. But again, it really doesn't necessarily
I
matter.
learned it the other way, so it doesn't matter.
Yeah.
It really doesn't matter, it's just they have to be opposite.
So you just pick, like,
Yeah.
you wanna pick?
Yeah, you can pick
Yeah,
them out.
either one will be right. It's just that if you have,
Yeah.
like, only 3, they all have to be the same. They're either all up or all down, either all plus 1/2 or all minus 1/2. Okay?
And like, it's pretty, like a bunch of different sources will tell you different ways to do it. Cause like I remember also, like I remember getting drilled in tosses, or being drilled that up was gonna be negative 1/2. I remember seeing the book, I think the other way, Mr. Hobbs did the other way.
Well, again, it doesn't matter, it's just know that if you have 2 electrons in the same orbital, you gotta have opposite spins, one's up, one's down. Okay, 'cause the reality is, they're really not even spinning, it's a weird thing that's going on, so.
Yeah, pretty much.
Well, I was gonna ask, does it always fill up, like going up first?
No,
Doesn't matter.
Not necessarily.
no, let me even just touch on that.
Yeah. Here you go.
Iron, Fe, is element number 26. Okay, where's iron's electrons? Last ones.
On the D orbital.
On the D, so it's 4s2. And then we have 6 electrons in the 3D. Okay, this is 3D. Now, that just as easily could be 4s. 1, 2, 3, 4, 5. Looking like this. Okay? So when we have a magnet with a north and a south pole, when you put iron into a magnetic field, all of the ups end up at one end, and all the electrons with the opposite spin are at the other end. And what makes a magnet unique, an iron unique, is that when you take it out of the magnetic field, they stay there. So the reason why a magnet is magnetic is because you got all of those spins of the unpaired electrons going the same direction lined up on each end. So the magnetism is the result of those electrons spinning. That's called ferromagnetic. Ferro meaning iron, and iron is the most common one. That's a permanent magnet. Now, there are some substances that will be affected by magnetic field, but when you take it out, they go back to randomizing, okay? That would be called paramagnetic. Anything that has an unpaired electron will do that. But if all the electrons are paired, group 2, 12, and 18, they're not affected by magnetic field at all. So all magnetism is the result of these electrons spinning. Little tiny things we can't even see, but they do a great job of holding pictures on the refrigerator.
So, if that's the case, does it make more sense for y'all to do as plus 1/2, because we can just do that?
Again, it doesn't matter.
It just makes more sense.
It makes more sense. Okay, so then we'll use that as the standard then. Because again, like Mr. Hobbs, like I've been saying, it doesn't really matter. But if it makes more sense to label these as plus 1/2 and then labeling these as minus 1/2, we'll go with that.
I just got confused because yesterday when he did it, he did.
Oh, yeah, he did. I thought he did the other way around. That's why I initially was like, what? So I went back and double checked on which way we're going to use it. But yeah, that makes way more sense for everybody. We'll keep it that way. Yeah. Use the restroom? All right, go for it. So, alright, and we can catch them up when we get back. Right now we're just doing practice problems, so. Yeah. So let's do an arrow diagram real quick, just to see if we're good on those. Which one do I want to be with? This one's less than samarium. I made a really long one, but that's just to get you practice on it. At the end of the day, it's just drawing it out. So let's do samarium.
Where's that?
And I believe that is, did I not write the, okay, I didn't write the symbol for it, so let's do mercury. We're going to do mercury instead, there you go, mercury, Hg. So this one's annoying because it's long, but if you can do this one, you can do literally any other arrow diagram in
How about we do like,
You want to go to zinc?
yeah, let's go to zinc.
Alright,
Why?
so,
I got this.
No, let's do mercury.
I got
let's
this.
do mercury? Okay,
No.
some of y'all want to challenge, some of you don't want to
Come
challenge.
on, let's do it.
Yeah, I believe you.
I don't know what I want to do.
Well, mercury's good because it covers pretty much every single orbital that we can cover.
By good lord.
Yeah, so let's go ahead and go through mercury and then we can go over it.
3.
It'll take a little bit, but yeah, if you can get used to doing this one, this covers all 4 orbitals, so you'll be pretty well.
4s is under 3D.
4s is under 3D.
4s is under 3D.
Yeah.
Does anybody remember why yesterday, from yesterday?
It's like the orbital has less energy on the, it's like held tighter in the S's and the D's.
Okay.
Yeah.
Because of the path, there's just a slightly different path getting closer to the nucleus.
It's erasers.
Yeah. 6 P?
Yeah, I think once it gets down to
There's gonna be a sign. No, there isn't. Yes, there is. No, there.
yeah,
Hold up.
3.
1, 2,
Three is
yeah.
purple. Because 1 is 2 is.
Holy crap, I got
3 is 3 P. 4 is.
Oh, good God. 5. We're up. 1S. 1S. 2S. 2P. 3S. 3P. 4S has more energy.
4 is.
And then 3.
I hate this class.
yeah.
So done. 3D
'Cause they will have to draw. I'm just gonna
has more energy than 4.
Oh, wait.
You gotta know the order.
Yeah.
That's
But
why
less energy.
you memorize it, you diagonal rule, or periodic table.
3, 4, 5.
You're still on mercury?
Wait, oh.
Is it on 5D? That's 5D2. 4. Oh, shit.
So AG's gold, right? Or silver?
Or AG is silver.
Okay, so AG's silver. AG is in 4D.
Yeah.
Okay.
It's gone.
It's like last year. So after 5P.
Yeah, there's a lot. It's 80 arrows.
S.
Yep.
Before D.
That's why I take Mercury. You can do this one, you could do any other arrow diagram that's gonna be on this.
See, like, if you can give me
I think I
this,
did it right.
I can
6
figure it out.
S, right?
Wait,
And then what's it go?
Like,
Oh,
use that
these-
really
yeah, so
long,
those
6, 8, 10,
There'll be problems like
11,
that.
15, 20,
Yeah.
22,
So,
24, 26,
if you
28,
don't know like what's above what, you can use little diagonal.
You can use the diagonal, but there's a even easier way to read it in class too.
No,
right?
then it would be 4
4S.
S. 4 S. So 6 S and then 4
You
S.
get it right?
So the first
Yeah.
D
Uh,
is 3.
I do.
So I would make sure
I'm done.
So
to,
on the first energy level, you only have S.
on
The
your
second P,
S and P.
spacing on.
3 S, P, and D.
Like use more
S, P,
space.
D, F.
Yeah, you definitely need more space, because you wanna make sure to show that like this energy level is higher than this energy level.
Really, you only have to remember through F.
The filling's right, yeah, it's just making sure that those energy levels are
So
right.
each energy level gets a new sublevel.
So is 4D above? Like,
Yes, above 5F.
4D's above.
D's are always just a little bit above the F.
That's P.
One's minus. One's plus.
So it goes 4 F.
I didn't get this high up on the diagram.
6P.
I stopped at 5P.
Ah, gotcha, yeah, so I mean, that's why it's good to go ahead and go to F, because I'm assuming there'll be at least one problem that involves an S
There's
orbital.
4 and a half, 5, 6, so it goes 5, 6 S, 4 P,
Success, 4,
and then the 6 P.
no, 5D,
13
then
and
6
3.
P.
So can it,
You don't go to
6S.
6, 5 D.
Alright,
Yeah, 5D after 4F.
you don't go to 60.
Six S,
Six.
5D, then 5P.
It's missing one thing in there.
3
Six
double.
S.
Good work.
So there's an orbital between 6
Okay.
S and 5D.
So it'll be 6S, 6P.
Hmm?
Times 3D.
Not bad. Remember, look at your, you can use your diagonals or you can use the periodic table just to figure out this one.
So I'm like 6S.
So what happens after 4?
4D. 5D.
You have to do it.
Finish your thought.
Yep. Looks good to me. Looks like we're mostly good in the hair.
It's that last little something.
You know you read this stuff? You're not read it at all.
It's that one.
Yes.
So that's the final, that's the final
Y
thing.
to the A.
Then we go back.
For the read, which is not coming to the
-1. This is negative 1.
You
1
got it.
times -1 is -1. Yeah.
I see it like that.
Oh, hold up.
Wait, we have.
I like it.
I don't know.
Yeah.
I didn't know, because I didn't know we had to do that.
2R cubic.
Gotcha.
is
I think, yeah, you
y
showed the,
squared
showed the energy balance.
is 2R
This is
y squared.
Wait, is D above 4S?
Is what above 4S?
Is
3D,
3D
yeah.
above
3D.
4S?
So this
Oh, okay.
this one right
Oh, shoot, my bad.
this
Here's what we can do.
Oh, take
Okay, now, all of this is
Oh my gosh.
last,
Stressing out here.
that's what is last one.
P squared, wait, negative.
And if you have 5 minutes.
Really dumb for doing this in my head.
Where do you find it? I just made that a little more distinct on like the
Negative 11.
difference between the two. Because it's already
5D.
so just make sure.
What one are you trying to do?
Wait.
Which one
Which one are we doing?
Just to make it individual.
So
Two
this is
times
Yeah.
okay, so 5D times D.
It is.
Excuse me?
So it's because 5S
one. Talk it out loud.
So the easy way to see that is, well, one you have your error, 2, right? But the other one you do is shooting at the periodic table,
5D,
and the way it's lined up.
Negative
So I can go into 5S right here, those two
It's
represent
very much
5S.
not negative 1.
This is 3D, right? So the next thing after here is 4D. So I know that's 5.
Wait, we need to write out both of them,
And
both
5D.
electron configurations.
So the, like the N, it would be like N6,
I need a fresh sheet of paper for
L,
this.
like 0, 1, 2, 3, 4, 5.
Oh, we're talking about, okay, yeah.
It would be
Did you write
five.
No,
that
no,
other
it would
one?
be, yeah, it would be 5, right? Because we're talking about 5D.
5D10.
Yep. It would still be, would be 5 in that situation because we're talking about 5D.
Oh, so you have to go through
Can you
like
put
5.
it down?
It's just, you just look at where, you wanna look at where the electron that you're talking about,
Mr. Hodge.
exactly where that thing is. Even if there's like 6S and stuff in the entire electron, it's just that electron represents.
So the N5,
Yeah.
L, like up to 4.
So yeah, I guess for this one, it would be L equals,
Like this.
the D.
Oh my god. Oh, what is that?
If you're in the D orbital, what is L?
Okay, so I need to have 48, I mean 80 errors, about 48.
that's the number of objects row, but specifically for these orbitals, is the number of. Remember 0 is S, 1 is P. And so you go for them. And then Isabel just counting your orbitals, and so like we did in the class last time, just basically figuring it like left to right, essentially, how it goes. Doesn't necessarily feel like that, but it's with something with 5d10, you're pretty much always talking about the last electron. If we're talking, we're assuming that last electron, we're assuming the end of the Isabel range. Yeah. So yeah, usually when we're assuming, we assume that it's in this last one. It's close, right?
Does it fill up all the way to
And then
5?
your spin could be, we're gonna use negative 1/2 because C say down negative 1/2, but it really doesn't matter.
Yeah.
Alright. How do we think we did on this mercury? Awesome? Confident? Okay, let's go through it. So, I'm going to save us the trouble just running through some of these. So, this is 1s, right? We know this one, we know 2s, then we know 2 p's coming afterwards, right?
Yes.
We got 3s, 3p, and then what comes after 3p? After 3p, and then it's rising 4s, right? Alright, 4s. After that, we got what?
3D.
3d. Then after 3d, we got what?
4D.
4p. I don't have enough room on this chart. Because I didn't write it. 5s. And then after 5s, we got 4d. 5p. I heard 6s. And then after 6s, we've got what? 5.
No,
4.
6.
4f.
6
I hear 4f and 5p. Why is who got me for 4f? Why is it 4f?
Because.
That's how it is.
Because it just is.
Because it just is. Okay.
That's
That's fair. I mean, from your arrow diagram, yeah, it follows after 6s, you have 4f. Also, if we look at the periodic table, we can do it that way. So, again, if I go down here, 1, 2, 3, 4, 5, 6. So this is our 6s here. And then right after our 6s is here, but remember from the periodic table that it actually goes down here, right? Because we have 57, 57, or 56, 57, and then we have this block of 14, which represents our F, right? So 6s, 4f, 5d, right?
So then what is LA?
What is LA?
What would like the final number of the electron configuration be?
That one is an exception that I
Yeah.
wouldn't even try to get
Yes.
into. Because if you look at,
We broke science.
no, one of.
Science broke science.
It's based upon experimental evidence. If you look at, the periodic table in your book, it looks like that. If you look at the periodic table in the AP book, the LA is down where the 58 is, and it starts that series in the AC is down in the bottom row. And then LU and LR move up to the top, the ones at the end of the bottom 2 rows. But experimental evidence, it does weird things. When those orbitals start getting really close to one another, the electrons kind of jump around a little bit. So one electron actually goes into the, what is that, 3, 4, 5D, and then the next electron goes into the 4F. Then in the next one, the electron leaves the D, and you have 3 in the F. So it just does crazy things that you're not going to have to worry about until you're graduate school trying to figure out quantum mechanics.
Is it LA 5D1?
yeah, I'm definitely
Well,
gonna take
it
that.
technically would be 5D1, yes.
And then
And then
8F 5D2.
CE is 58,
So that's 4F1.
yeah.
But then you go
But
back.
then you go to praseodymium, and you can't take the D's, disappears, and you have 4F3.
Yeah, that's why we don't do.
That's why you don't have to worry about the exceptional ones.
Yeah, that's why most of the time we're not going to give you an an electron that resides inside of these, because it can be a little weird with bearing a few exceptions. Usually, if we give you an f orbital, it's going to be talking about an electron that's after the f orbitals. It's just knowing that you know where the level is as far as energy goes. So yeah, 6s,
That's so weird.
4f, and then if I had room, this is going to be our 5d. I'm not going to be able to fill that, nor that, but I'm assuming that we filled all these orbitals like so, or like with just up arrow, down arrow. Either way is fine as long as we know that there's an up spin and a down spin that we're working with. And where do we stop filling it?
All of 5D.
5D, so we
5d10.
5d10, so we filled up the entire 5D orbital, right? Cool. Everybody in agreement there? Anything not make sense in that one? Yeah. Like
Can we do the little quantum number thing?
the quantum numbers? Oh yeah, so we can do the quantum numbers for this. So if we're talking about this last electron right here in the 5D, what's going to be our N? 5. What's our L? 2. All right, what's our M sub L? 2. All right, and then what's our MS?
Minus.
It doesn't matter. It depends on how you want to do it. If you like down as -1/2, we'll do that. If you like down as +1/2, we can do that. Again, this one doesn't matter as much. For the consistency, since most of the class agreed that it's easier that way, we'll do down as -1/2 and then up as +1/2.
How is L2?
Yeah, why is L?
Because 0 is S, 1 is P, 2 is D. And it's on the D.
Yeah, remember you start at 0 with the L's, not 1.
And
Yeah.
two ones friends.
All right.
And then M sub L is the -2, -1, 0, -1.
Yeah, M sub L is from negative L to positive L. So M sub L is talking about, like we're saying with the room assignments, essentially the hotel analogy, where you've got your L and then you've got your different orbitals inside of that L sublevel. And so that's what we're talking about here, which is just the negative L to positive L. So it could be 2 if we're talking about this one right here. Which one would it be? What would be the M sub L if we're talking about that orbital?
-1.
-1, yeah. So you move it back a couple. From -2 here, -1, 0, 1, 2. Make sense? No problem? Okay, cool. So, do y'all remember, like, when I first got here, 2 months or so ago, we did a game about sig figs.
Yes.
Oh my god.
Oh no,
Yes.
it's gonna take 10 minutes.
On the whiteboard.
So, yeah, we're going to be doing that today.
Crap.
Sat there like,
I was like,
So,
Oh, yeah, and then Caroline.
we are going to have to, if y'all want to start back, just go ahead and flip the teams. Let's see.
boys versus girls.
That's kind of outnumbered.
This side of
What's
the class
Jackson?
versus that side.
Oh, wait.
Yeah, probably,
Right.
probably left versus right
If you're on
side.
that side of the split,
No.
Probably left versus right side. So let me.
Caroline pulls
Yeah.
off all
What side
Actually-
am I on then?
you're on the right side.
Sam's right.
I'm just gonna be
You're on that
half.
side.
I didn't realize.
You
the teacher.
Alright.
He's on that
So, you can help you guys.
Whiteboard here.
That's fair. I think it's really
Let's go.
That's fair.
It's gonna be really bad.
Don't worry, aerograms. If we
I'm
get
going
Okay,
to
that's not bad. They have
Where am
Peter
I?
and Keith and
Caroline's on
Care.
the right. You're on the right, Caroline.
I'm answering a question. You
Jackson.
No chance.
Alright.
Jackson is.
Caroline's on our team.
Jackson's over here like, whoa.
Jack,
Hold on.
No, it'll be
Who
fair
said I was
now.
gonna get this stuff right?
What do you mean by that?
They'll have one more than us plus Caroline.
Yeah, Caroline counts as like
One
half
more
the
plus
person.
Caroline.
She
Okay.
should be on our team.
Caroline is not half the
Okay.
first. Caroline's like at least 2.5. But like sig figs and all that crap. Like
Okay,
2.5
so-
you might have like 6 2.
Caroline, you're on the right path.
Whatever. I'm gonna answer a question
That was like
and
180 for first.
Alright.
So,
get it right, get it right, get it wrong.
I
Tough.
could basically be on whatever team I want. No.
I'm not
I
writing
love
the
this
full-
game
I'm
so
not writing the
much.
full one.
I'm writing it so
I'm writing down that last number.
I'm writing it so slow. It's like, what is that? The right answer.
Whatever you want it to be.
Everybody have markers on
My
them?
marker doesn't work.
Here's another one.
Hey, bro, look at this eraser.
Awesome.
Okay.
Let me know any parts of these aren't working, and I will grab you.
Like
purple. Yeah, that's just kind of distracting. Okay,
Yo, mine is weird.
so,
I kind of forgot.
Are we doing 6 phase?
No, we're not doing six.
No, Jackson, we're past
Hey,
that.
remember when we did
Okay.
Yeah, way past that.
so 1, 2, 3, 4, 5, 6.
Remember when we were doing six?
No, I think we should do another test on sick day.
I thought we were.
I think we should not. I think we should pass on that one.
test says otherwise.
So yeah, I mean, basically, we're just gonna do 6 and 5, so this side, these 3 tables in the back here is 6. Y'all have 5 on this side.
Bruh.
The C in Caroline stands for carry.
Hey, I'm on this side.
Okay, do y'all wanna do team names, or do y'all wanna do left and right?
Yes.
Yeah, I figured y'all wanna do team names, what do we want?
We
Oh
lost.
my
We're the
God.
Carolinas.
We lost. Team lost.
Team lost? You better have more confidence.
Oh,
Team lost.
Yeah, y'all can believe in yourself.
Now y'all can get mad at me when I get a question wrong.
No,
Listen,
Travis
Travis
Scott.
Scott's different. Caroline, what's
Travis
Travis
Scott.
Scott? It's arrogance.
What?
Travis
We have
Scott
Clay
burger.
versus Caroline on our team.
Can we be Mikey's though?
Yeah, that's gonna work out so well.
So, what? So, okay, if you're, I'm just gonna call you Team L.
Yeah, no.
What?
If y'all really wanna go by that way, we'll go
Yes,
that
we
way.
do.
I think y'all are gonna be fine, and y'all are gonna
Travis Scott
do well.
burger.
Travis Scott burger.
Alright, what about y'all? What do y'all think?
Travis
Travis
Scott
Scott burger.
Travis, just like last time, huh? Is this how we're
No, we
doing?
were team Gunna.
Last time.
We were gonna last time.
Yeah, we were.
No, you're like team,
What?
same team.
No, I wanna change our team name.
Oh, you
No,
asked the
no, we don't.
question,
No,
then you
no,
write
no.
down the answer and hold it up. It's
Can
pretty
we
easy.
change our name?
What, what's your name? Y'all wanna change your name?
Yeah. You just ask a question, whoever
COVID the back.
holds it
No,
up
no.
first.
Wait, what?
And gets it right.
What's going on?
I hate all of them.
COVID. C.
Hobbs, can I switch classes?
D.
Go ahead and move to the AP camp.
Clay.
Like Vivek or something.
That's
No, wait,
Vivek.
that's not right.
No, you gotta change.
No,
Oh, no.
There you go.
Okay, there you go. Alright,
Caroline.
so let me go ahead and turn on.
Travis Scott burger. Yep, that's my team.
Hey, I think
Hey, Bad
Mm.
Bunny.
That sounds like a lot of
The
pride in
Bad
the team name.
The Bad Bunny people.
Hey bro,
Yeah.
you smell that out there? Smells like doves.
And the Travis Scott burger.
Wait, where's the,
They don't sell this anymore. It's Bad Bunny meal only.
okay.
Nah, bro.
The Bad Bunny meal.
Isn't it
Well,
like,
I'm not sure
Stop
why
being
everybody
so
gets
sweet,
excited
chicken
on
nuggets,
that.
like,
It was
I've seen that
just
one guy where
cheeseburger,
he did Travis Scott.
yeah, it
barbecue
wasn't
sauce.
that hype, it's just the Travis
I don't know,
Scott.
I've
Bro,
never
you
had a burger from
you go to
McDonald's.
Five Guys, get a double bacon cheeseburger,
I only
super
get their
greasy
rolls.
fries,
Hey,
and
I'm
peanuts.
working on a review in here.
Yeah, we like.
And 3
So I gotta get off this.
Yeah, where's the PowerPoint?
what's PowerPoint?
Oh, I need it.
That, ooh, answers.
I don't see it.
Oh, it's
Quick draw.
right there.
I got the quickest hands in the
Okay, this is not.
Quick,
Yeah, I'm not gonna-
quick draw.
They call
We
me,
get to see it before they.
they call me the Arizona
Yeah,
Rangers for
um,
reasons.
Caroline, what you shaking your head for?
Take this game.
Caroline, it's such a neat-
Okay, so, same rules as last time, first team comfortably answered, gets 1 point. Correct answer on the first attempt is 1 point. Correct answer in general is 1 point, and the points stack on top of each other, so max of 3 points per problem.
Periodic table.
I have the answers right here, so I can look at them and make sure. Okay, so first up is element. So I'm gonna give you an electron configuration, and/or arrow diagram, and I need you to give me the element that's associated with it.
can we just put the
Okay.
abbreviation of it, like the GE?
Yeah, you can put NA, you can put like S, you can put AG, whatever it is, just the, yeah.
I got you.
Hold up.
Okay?
Hold up.
For this one.
Alright,
In a race.
I'm sitting back watching that Caroline's board look this.
okay. Y'all ready?
No.
Yeah, let's go.
Yes?
I'm,
Yes?
I'm running.
Follow my nose.
Okay.
What?
Wait.
Oh,
That's too tiny.
What is that?
Oh, it's too tiny. Oh,
Oh,
no.
wait.
Wait, how do I make it bigger? Plus.
Oh.
Is that
Oh,
7?
no.
Hit control
No.
plus.
Was this it?
No.
There it is.
See.
Wait, what did you write?
Caroline's got it right.
Y'all saw that?
Bro, I thought it was.
No.
I thought it was big
That don't
enough.
count.
Was it oxygen?
Yeah, okay.
Caroline's on some.
on.
You see that?
Okay. I'm gonna
That's
call
oxygen.
these out
That's
though.
O.
Got that 2020 vision. I haven't gotten my
Actually,
tags
I
in like
think
10
that's the
years.
zero diagram.
Yeah.
Okay.
2P4.
I think that's the only one that might be zero diagram. So,
Caroline.
Is that
all I
oxygen?
see are
yeah, it's
dots.
oxygen. Yeah.
Bro, I
Wait,
was
that makes
That is
Yeah,
a
it's
Morse
oxygen.
code.
We won't count that one because, yeah.
No, no, that is
I
a
can
Morse
still see.
code.
I can read it.
I can't.
I can read it.
Yeah, I can see it, and I already have the worst.
I
But it
can-
wasn't a plus size thing, but it wasn't plus size.
Has nothing
Oh,
to
that's-
be doing up here.
Okay, so you're, okay, so you're making excuses then.
Count it.
Can I get 1 point for my eyesight, please?
Roll shoot up, I can't.
One person saw it. That's all it needs. That's all. Someone saw
My -5 vision saw that.
Alright, I'm just gonna do 3 and 2.
Let's go.
We're just-
What?
we're just-
Wait, what?
Bet.
Wait,
Did
why
anyone
is it
raise the board?
That one was weird, that was a weird one. Okay, but now that we know we can
Trying to skate.
we're gonna keep going, alright? Now that we know we can see, no more excuses, okay? Alright, so yeah, we're watching.
Good job, Caroline.
Next up.
Oh, my mark,
That's
no more.
okay.
That,
We
keep
got
going
right.
Wait,
first.
isn't it?
Yeah.
Yes, right?
Yeah, that's correct on the your side.
What do I
So,
do?
you got a correct answer, but Team Travis Scott Berger got it first.
I was
So,
trying
yeah,
to write mine
it's
down.
a-
My marker.
What you right?
Okay. I was like, okay.
Jackson, what are you
Let me
talking
give you a
about?
hint though on that one, you don't have to count.
You just look at the last
It's
one.
4S1, so it's on the 4th row in the first one in the S section.
We would
I
have
did
won
that.
out
I
with
put it.
my
I
marker.
counted it at the time.
I sat here and I was like, yeah, it held up the
If you
board,
have
was like, it's
Joker
not
right
there.
to it, I'll take it.
Alright, you ready for the next one?
Lucky bombs.
No.
Alright.
Oh boy.
I'll use
That's 5D3.
5P3,
5D3 or 5?
P or D?
D.
Yoink.
Nope.
Oh, what's that say?
No.
Oh, wait a minute.
Here. We got first. We got first.
I did the wrong way. Let me double check.
1, 2, 3.
Sam just, he literally.
No, I didn't. I literally looked at the thing.
Oh, you know what I did?
Look on where he's OT.
When I did this problem, I did the wrong periodic table because I was using the AP one and not the
There's a different periodic table.
Well, it's just where that lanthanum, but I mean, it's still
Yeah.
D3, it still should be tantalum.
Yeah, it's okay.
Yeah, that was me.
I put it first.
Yeah,
Killing.
think,
You are killing me.
yeah, I'm pretty sure y'all did it first, yeah. So yeah, when I did tungsten because I wasn't paying attention, I saw PG. So, it is
Did you say Sam just come on?
No, I didn't. I literally looked at the periodic table. over
Yes,
there.
sir.
Yeah, because I did the wrong period, or I did, the periodic table that I have, that I use was different.
Wait, W.
That's on me.
Oh,
Oops, why did it, okay.
wait, what? Drawing it
Yeah, my periodic table basically had that removed, so I was just like, oh, that's okay, so, that's on me.
Oh, wait. Oh.
Okay, are we ready?
Yeah.
Okay, yeah.
Oh.
Yeah, that was immediate from Caroline, yeah.
Bro, Caroline, look at this.
isn't it?
What? Yeah.
That was immediate, yeah, and then
I'm not sure how Caroline raises her.
I'm just trying to figure out how you read that. Right?
I actually
She doesn't memorize.
Ready?
She doesn't memorize.
Alright. So, we got
A lot to not much.
not much.
Oh, no.
Eight.
They're
No.
beating us by.
I don't want to do this. I don't like
Alright.
this one.
Electron configurations.
Okay.
It's you.
I'm gonna give you an element, that's just ion, we're not doing ions. You can use the noble gas notation. So if you know how to do the noble gas notation and do it quickly, you
Everybody's
can use
looking at their
it,
periodic
if
table.
you'd like to.
This is literally who can write it faster.
Not me, bro.
I'm saying.
Or if you
Maybe.
can get it.
That's who can find it faster on there.
Who can write it faster?
Alright,
That's when we got to get it.
carbon.
Nah, I got that first.
Oh, yeah, actually, yeah, I got it first. Yep, and right.
How do you write this?
Chuck.
You don't try to write it neat, you
Yeah,
try
that's
to
right
write it to
there.
get the dub.
You're missing something on that one.
Wait, he got
Yeah,
right.
there it is.
Yeah, you got it right.
Good.
Yeah, Clay was instant on that one. 1s2, 2s2, 2p2, or helium 2s2, 2p2.
How would you like this?
How do you write it that fast?
Did you just squiggle it and say that's the right answer? Let me see your board.
Hey, don't be hating this
Come
one.
on.
Oh.
Don't be hating that we're coming back.
Alright.
Cheat.
Yeah. Watch out.
He's cheating, bro.
Same thing happened to all of Trump's votes.
This disappeared.
Alright.
They were there.
Yeah.
They went away.
Smoked.
What does that say?
Is
What
that
is
the-
that? What
I
is it
can't
on?
see it.
Okay, this is,
What's the last ones? What's that last?
what's the last one here? Oh. Okay. It ends in 4D. It's got 6 electrons in 4D.
Oh wait, we're not in element, are we?
That's like sick. Wait, why are you doing this? Wait, I should be writing this down.
Oh,
Wait,
Ah.
which element it is?
What?
It's not the symbol, but I think I know what you're going for.
Oh.
Wait, wait.
Oh.
Oh, shoot.
Is this right?
I give up.
Is that right?
Oh.
It says
Wait,
krypton.
were we just writing the element or
We're
the?
not doing
It
this.
says
We're
krypton.
doing the
Oh, okay.
electron configuration. No, that's not right.
That says
That's
krypton.
right.
Wait, let me see.
That's right as well.
Well, I had it. I had
You got it
before
first.
him.
Yeah,
I
you had it
before
first.
him.
Yeah.
Calm down.
Sam's on our
I
team.
was just figuring out.
Yeah, I put this. I try to remember to just throw this. This is done, and there's a way to throw in a loop, but because of the whole not being able to see it well,
Oh,
kind of makes
Wait,
it.
why is this one
right?
wrong?
It's just not the right.
Oh.
Yeah, we were doing electron configuration.
Hold on.
It's on the board right now, just an arrow notation or arrow diagram.
So do I have to turn it around like that way?
Wait,
Yep, that's well. What's your S orbital that you use?
do we still have to do it?
Wait, yeah. This is like a-
You're
Get your
missing
point.
a level.
You do it.
3 points.
Yeah, that's it.
We're getting closer. We're only 2 points behind now.
What am I missing?
Better watch out.
All right. So I'm gonna put it on board. It's this big one. So it's krypton 5s246.
Yeah.
This is iron.
No, it's not.
What? Is it not?
No.
4D.
It's
No.
the one below.
Oh
It's
my
already
goodness.
in.
3D.
I need to go through. I double checked this too.
This is
I'm so
RU.
surprised. Yeah, this is RU then. Okay. So then let's see. That frustrates
That's
me because
why
I
are you
checked this
jumping?
twice to make sure that I got the time. Okay. Well, regardless, the element's wrong, but that is right based off this. So if you got the 5s246, you got it right first. It's just that the element's wrong. The element's different.
So wait.
It's still 5s246, right? Just look at
Yeah.
look at the thing. 5s2 right here, 46. Right here. 1s2, 2s2.
Can this round be worth 6 points for the winner and 0 for the loser?
No.
So is this
You're in a
tech,
2-minute drill. 2 minutes.
is this tech?
No, it's the one right below. It's the one right below. Iron.
There's one right down the
It's ruthenium right here. So yeah, I put that in wrong. It's not iron, it's ruthenium, but the electric configuration is what we're looking for.
That's why, I saw that count as
It has
3D.
4D7, 5S1.
Yeah, that's
Okay.
one of the exceptions,
Yeah.
but for what you would have to do, 4D6 would be right.
Yeah,
So
It
this
makes
was
absolutely no
RU.
sense why it's.
yeah,
that.
exceptions don't make much sense.
So was
The only ones
this,
that really kind of make sense is maybe copper, but
was this a RU?
even now.
Yes.
Yeah, this is already. So that was on my fault. That should have been iron, but I guess when I went
We
through
got
this.
time for one more.
Yeah. Okay, so I'm gonna go skip to quantum.
No.
Okay. So I skipped a couple.
Oh, yeah, that'll probably help.
So, I mean, this one, yay. This one, yay. Okay, we're gonna do the third one. Oh, we're,
Okay, get everything back in the Ziploc bag.
what?
That's a point though.
That's the point?
Yeah, we won the first one down.
Put everything back in the Ziploc bag.
We don't have a Ziploc bag, I'll come by and pick it up. Sorry, that one we just ran out of time. There could have been a chance to come back.
Bonus
If
point.
you Hey, if he doesn't wait on us, we're gonna make a big deal about it.
Oh, I'm going on.
We literally had Carolina.
We won by default. We had Caroline on our team, bro.
I'm gonna scroll back. I'm gonna scroll back through all the text and copy and paste them from what she said.
Yes, sir.
Hey, y'all did fine. Both y'all got the right answer. Caroline was a lot faster, a lot of faster. I hope y'all were faster than Caroline.
I think she knew the answer before. Put on the board.
You think I said the answers to her?
She studied the slide.
So what you're saying is that she studied the material?
Yeah.
Yeah, like.
She studied the slide used as the game.
Alright. I'm actually surprised, because I actually went through and double checked every single slide. And I still had something wrong with it.
That's a common one because if it's on the Ford Pro, so we instinctively want to think it's.
Yeah. I kind of brain deaded that one. And I guess the one I had is weird because it didn't count lanthanum in 57. I think it started 57 later, and so it just kind of like, I don't know what happened with mine because that one tried to go on there.